This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
This episode of Software Engineering Radio is sponsored by Datadog. Datadog is a monitoring platform that helps thousands of companies get visibility into cloud infrastructure, optimize application performance, and avoid downtime. Datadog integrates with more than 200 technologies so you can get immediate insights into all of your databases, your web servers, cloud services, and container technologies like Docker and Kubernetes. Start a free trial today at datadog.com/SERadio.
For Software Engineering Radio, this is Robert Blumen. Today I have with me Edson Tirelli. Edson is a senior principal software engineer at Red Hat, where he is the JBoss Drools / Red Hat BRMS project lead. Edson is responsible for the roadmap, architecture, development, and delivery of the Drools product. Edson is also a researcher with a focus on artificial intelligence and rules engines. Edson, welcome to Software Engineering Radio.
Thank you, Robert. Thank you for having me here.
Today, Edson and I will be talking about rules engines. But before we start, Edson, would you like to tell the listeners any more information about yourself that I didn't cover?
No, I think it's pretty much that. I've been working for a long time, for the last about 12 years in the Drools project. It's a passion of mine, and it's something that really interests me, so always happy to talk about it.
Great. Let's start with some basic prerequisites. What is a business rule?
A business rule is something that is defined or is used by a business to execute a process or to make a decision. An example of a business rule could be, for instance, the tax rate on a given product that the company sells, or, for instance, a policy. The company says, customers older than a given age will receive a discount. So those are examples of business rules.
Business rules must be quite important in the operation of a business. Is that the case?
It is. No business can operate without following its own policies, own rules, or even government laws.
Do business rules have any internal structure if you drill down into a rule?
Yes, it's very common to have a condition or a set of conditions and then a set of consequences derived from those conditions. There are different types of business rules, but that's the general structure.
Can you give an example?
Yes, for instance, in the example of a company policy that says customers older than 60 years or 60 years older or more will have 50% discount on the ticket for shows. This is a set of conditions. The customer has to have 60 years of age or older, and the consequence of those conditions is he gets 50% discount on the ticket.
Okay, rules have two parts then. There's the conditions when the rule applies, and consequence, which is something that happens, or a value, or you say a bit more, what is about the consequence part? Is it an action or a value or a number?
It's both. When we're talking about the traditional business rules, they are called production rules. They have usually an action or more associated to that. When we're talking about decision services, that is a separate part of the business rules discipline, then decision services usually return a value. So they are both business rules. They're both styles of business rules.
When are business rules applied or executed?
When the condition is met, typically it defines a scenario, and whenever that scenario is found, when those conditions are fulfilled, the business rule executes.
I'm familiar with many systems that are request-driven. For example, e-commerce, the person is checking out their shopping cart, At that time, I might want to know, is the customer entitled to any discounts, or what is the tax rate on the customer's order? Are business rules executed on a on-demand basis as a service?
Yes, that's a very common case, and this is what is called the decision services. So you have something happening, for instance, the customer is clicking checkout on the website, that triggers the execution of that service to decide about something. There is also other types of business rules that are triggered by conditions in real time or in batch processes.
Could you go into the real-time case a bit more?
The real-time case is more about when you are monitoring, or the system is monitoring conditions, and it receives events that trigger those actions. An example would be, for instance, in logistics, where you're monitoring your traffic, your trucks, and you receive traffic alerts. If there is an accident, for instance, in a given intersection, and you have a truck heading towards that, you might react to that event, the accident, and reroute the truck through a different road that is free, that is open, basically.
Something I see a lot in my job in DevOps is we have alerts set up where if CPU load is greater than 60% on this instance for 5 minutes, we page an on-call person to investigate. Would that be a good example?
That's a great example. This heads more towards another discipline inside the business rules called complex event processing, where you are monitoring systems in real time and then you take actions on those systems. So this is also a very common and very important use case for business rules.
Okay, that sounds like something I want to come back to, but I want to go on more into the basic rule systems. Okay, so it sounds like a set of rules would apply depending on the situation, like customer checkout, or can this person be approved to get a loan? How many rules does a business have? Maybe give a range. What's a very small number? What is a large number of rules?
It depends really on how much the business can automate, but the typical case would be a few thousand rules for a small case, several, dozens of thousands for a medium case, and the largest cases I worked with, they had about 1 million rules or more.
Wow. That's going to raise some very interesting questions about implementation, which we'll get to later. Right now, I'd like to delve into our main topic. What is a rules engine?
A rules engine is a specialized component of middleware that is capable of executing rules. The easiest way I have to explain is make an analogy to a database that is very common for all software engineers. A database allows you to extract data from the application and manage the data lifecycle externally. You can do optimizations. The algorithms in the database can execute tasks much better than if you would implement those tasks yourself in application code. So a rules engine is the same thing, but for business rules. It allows you to extract those business rules that could be implemented in an imperative language. You extract them, treat them as data to the system, and manage the life cycle of those rules independently. The rules engine also in runtime has optimizations that allow the engine to execute those rules more efficiently.
Okay. And Edson, how are the rules expressed by the programmer to the rules engine?
There are several ways. We call them metaphors. Very common metaphors are decision tables. They can be, they are just tables where each row on the table is a rule, but you can use specialized languages. We support several of them. Our native language is called DRL. It's a declarative language.
Would it be fair to call that a domain-specific language for the rules domain?
We do support domain-specific languages, and as you know, it's called DSL, because then you can make them really specific to the domain of the customer. We usually call the the native language a technical language because it's really technical. It's more for programmers.
If I understood you, then you're saying that suppose the domain is insurance, you can develop or implement an insurance-specific DSL on top of the base language that Drools supports?
That's correct.
Okay. Would it be fair to call the base language a domain-specific language for rules in general?
I haven't seen it called that way, but I guess it's a DSL for rules. Yes, it is. It's a bit more technical than the typical DSL that I know of, but yes.
And why would I want to code? We can write business rules in any well-known programming language. I'm sure every programmer has written rules like you just entered age on a web form. Let's verify that age is a number, that it's a positive number, that it's less than 150. Why would I want a specialized language for writing rules?
Because you switch, usually when you implement in the application code, it's typically imperative languages, Java, JavaScript, C++, whatever. And when you implement those in a traditional rules engine, you are using a declarative language. In declarative languages, as you know, you only say what you want to do, not how you want to do. The rules engine is responsible for figuring out how to do that task, how to match and execute that rule.
We did a show on declarative languages recently in relation to infrastructure.
Mm-hmm.
Why is a declarative approach a good approach for rules? What are the benefits of that?
For a starter, it's more productive. You can do more in less time. But the main reason I would say is because it allows the engine to do what it does best: optimize and decide how to execute your rules in the best possible way.
Okay, I want to come back to that in a minute, but first one more question about the language. On software teams with very rules-intensive applications, do you typically have one or a few programmers who specialize in the rules language and work with business analysts, or does everyone learn it and it becomes like embedding SQL in your web-based database application where it's a skill that generally everyone has?
This is very specific to the dynamic of each team, because there are metaphors and there are languages for rules that are higher level and targeted at business users, or a slightly technical business user. Just to mention an example, there is a standard called Decision Model Annotation, DMN, that is very high level, targets business users, and they can develop the rules themselves. And there are very technical languages on the other side of the spectrum, in the case of the native language, that really requires developers to work with that language. It's based on Java, so it's very familiar to Java developers, but it's a technical language.
This is a common issue. How did the business and engineering work together? We're software engineers. We don't know whether somebody should be given a loan or an insurance policy or not. The business is going to define that to us. There's an impedance mismatch, or there can be, between how business understands their business and how we write the code. How does the technology, does it help bridge that impedance mismatch?
Absolutely, and this is one of the holy grails that we target with this kind of technology and this kind of methodology. And when you look at the higher level languages like DMN or like decision tables, those are the abstractions that allow business users and developers to speak the same language, to understand each other and look at the model and see, and both understand this is what is being executed, and it does match what the requirement, what the description of the business rules are.
Great. And now I'd like to come back to the runtime, which you mentioned a moment ago. I want to start with a simple case. Suppose a business has one rule. How would the rules engine execute that one rule?
Well, it would just, try to match the scenario and execute that rule.
Okay, could you walk us through a simple example of somebody's requesting a loan and we have a rule about their income? It has to be greater than $20,000 to get the loan. So how would the rules engine operate on that?
We work with what we call facts. A fact is basically a data object. So the data object would have, the customer application and would have an attribute there. That attribute would be the income, and the rule says if the income is larger than 20,000, then it would execute an action, for instance, concede the loan, right? But the rules engine compiles that rule into a data structure, and that's an optimized data structure. It's not like an if then else in a typical programming language. That data structure is responsible for actually executing, checking those conditions, and then executing the actions if those conditions match.
Sometimes these questions don't work great on an audio podcast. Can you say any more about the data structure?
Yes.
What it looks like?
But to do that, I will use a slightly more complicated example. Imagine that you have a customer data type that has, for instance, the status of the customer, VIP, for instance, or a gold customer, silver, and etc. So imagine you have 10 different values for that customer. And then imagine you have 10 different rules for each of those values, right? So basically, if you were implementing this into a typical rules engine, you would have 100 different if clause in your Java program, for instance, right?
So based on the tier of the customer, they get a different preferential price, for example.
For example, and then a different shipping rate and etc. Each of those is a condition. So basically, you would have, if you were implementing Java, 100 different ifs in there, 10 different values times 10 rules per value. You would have 100. So in Java, when a computer is executing that program or any imperative language, it would check every one of those ifs one by one, and then the ones that match executes the condition, right? A rules engine compiles those rules and checks what is common between them and indexes them in memory. So instead of checking 100 ifs one by one, that data structure aggregates those similar values, those 10 similar values, into only 10 clauses, and then index them so that it doesn't even to execute even those 10. It just understands that if this customer has a type VIP, then only that rule, that set of rules will match, and then it will only execute that check once. So this is the kind of optimization the rules engine will start doing behind the scenes.
If I understand, it might be like a database where the simple way to search is search every single record, which results in a table scan. You have an index where, based on the value falls in between certain ranges, it can go directly to a segment or an area on disk where those records are. As I understand, it's not exactly the same. Is that a good analogy for what?
That's actually a great analogy. It's a much better way of explaining than I did, so thank you.
Okay. Now, a moment ago, you mentioned that the rules engine has access to facts like the customer's income or their age or the tier, the gold or platinum tier. Where do those facts come from?
They come from the application. So from a rules engine perspective, we have adapters to different data sources, and we integrate with projects like Camel that will bring that data into the system. So they exist in databases, in files, or if it's a REST service, web service, it will come as a request, and then that data is unmarshaled and then inserted into the engine so the engine can do the evaluation.
I see. Broadly speaking, then, the facts could come from the request or any type of persistent store or non-persistent store I have where there's facts or attributes that I consider relevant to this situation.
That's correct.
Okay, great. I would like to get into a more complex case, more realistic. What happens, how does the rule engine work when you have a lot of rules? You said you could have thousands or tens of thousands. What changes?
The algorithm that compiles those rules into a data structure is very efficient for increasing number of rules. So the best way, I think, to describe this scenario is that for an increasing number of rules, the order of complexity of the rules is constant. So when you have a knowledge base or a rule base with 1,000 rules, and when you have a knowledge base with 100,000 rules, typically the response time for any rules execution will be very similar, will be constant. So for increasing number of rules, we don't increase the response time.
Okay, the engine then, it has a way of organizing the rules efficiently so it doesn't have to execute or search every single rule for every single fact.
That's correct. So that internal data structure is basically a discrimination tree, and then it will organize and index the rules so you actually have a very efficient solution for increasing number of rules.
Okay. Now let's say we're trying to determine if the applicant will be granted their insurance policy, maybe rules on age, their health, their income, where they live, their zip code. How does the engine determine what order to execute these rules, or does it do them in parallel?
It depends on the way the rules are declared, because users can define priorities. So rules that have higher priority or have a specific flow, they will be executed first. But if no priority is given, or if the same priority applies to a group of rules, then the rules engine will execute them in the way that it optimizes the most. So whatever way has the best optimization is the way that the rules engine will execute them.
So to be an example, if we had a rule of if your income is greater than $1 million, that would immediately eliminate the vast majority of the applicants, then you might want to execute that rule first, because it could result in that you don't have to do any more rules after that.
Yes, that would be a higher priority rule. But if an applicant has a income lower than that, it will not even touch that rule. The rules engine knows this, and it will not even try to execute that rule.
And it knows that because it's built this index type structure.
Correct.
Okay. Now, you talked about customer might be in the gold tier or the silver tier. Could you have rules that chain on the results of other rules? Like, for example, we have a rule that says if you've done 10 transactions with this company and you spent more than $100, we're going to classify you as a gold customer. Then we have another rule that says gold customers get 10% discount. So you have to execute those rules in a certain order. Does the engine figure that ordering out?
Yes, and this is a great example. This is called chaining, and the mechanism is called inference. So if a rule changes the values or understands that those values affect the reasoning about other rules, those other rules will be chained and executed after. And there are two types of chaining. So
right. Okay. So I do want to ask you about the two types of chaining. But one other question, that we have a rule that determines that the customer is a gold customer, and now that becomes a fact. So rules in this case can have, in other language programming situation, I might call this side effects, where they change facts and then those facts affect other rules. Is that right?
Yes, that's correct. That's perfect.
Okay. So is it really a good idea to have a whole programming model based on side effects?
Well, the side effect in this case is local, and it makes the development of the systems much easier, right? So it's not a side effect that is persisted. It can be persisted, but it usually it's not. It's local. It's part of the reasoning process. So why it makes the system much easier to develop is because you don't need to think about everything at once. Each rule is independent, but the rules engine will find out those dependencies implicitly and will chain them together implicitly.
I see. If I didn't have that engine and side effects, then I would have to think about what are all the possible outputs of this one chunk of code, and then finish computing all of those and then call another chunk of code. It would put all that complexity onto me as the programmer.
Exactly. So in your example, using the mindset of the developer, all the developer has to do is say, well, there is a rule here that says if there are more than 10 transactions, this is a gold customer. That's all he needs to think about. And then he looks at the requirements document, and the requirement says if it's a gold customer, receives 10% discount. That's all he needs to think. And the rules engine will find those relationships and execute them in order as necessary.
Is it a problem in practice that you could have side effects chaining in such a way that it never converged to a solution?
It is possible. It is a Turing-complete language, but there are mechanisms that allow us to control this and minimize the risks of this happening. Also, as any software engineering methodology, you go through tests to make sure that you are not reaching an infinite loop or something similar to that.
Okay, so this is not a question, but a comment. Then if we had 5,000 rules, I could see that as a human being, I could maybe understand, or a team of several people could understand all those rules. If each rule is fairly simple, like the person who has 10 transactions is a gold customer, but to try to understand all the dependencies between those as a human, that sounds impossible.
It is not supposed, you would not have to worry about this because the engine does this for you, but a very common requirement is to have audit logs on all those decisions. So basically what you do is you submit a case to the engine responds with a set of values and an audit log why that decision was made. And in the audit log you can see, this customer had more than 10 transactions, so it was classified as a gold customer, and that activated that other rule for gold customers, and that gave him the discount. So the audit log is a very common requirement that is provided by the engine itself.
If anyone then has a question, why this person was denied a loan, and there may be laws in that state about discrimination, that you could show that you applied certain rules and that those rules are all compliant with the regulation, and that the rules were applied consistently to everyone and no one was singled out for worse treatment, things like that.
Absolutely. This is a very common use case.
This podcast is supported by Atlantic.net, hosting solution provider of healthcare HIPAA, PCI compliance, and ad tech. If you're feeling the pain of having outdated technology, call Atlantic.net and get the latest security firewall, intrusion detection, backup, disaster recovery, and virtualization. Or if you're starting a new project or not getting the results you want from your current providers, Atlantic.net can help you succeed. With fully audited solutions and 23 years in business, they won't let you down. Visit Atlantic.net to learn more.
Okay, back to, you were talking about a moment ago that you test the rules. Is it realistic when you have this many rules to come up with a decent set of test cases that covers enough different combinations that you've got a good assurance that it will work?
Yes, it is common to have things that people or that companies do are they take, for instance, snapshots of their production data and save those snapshots, and then because the results are known for those snapshots, they can rerun that at every release to make sure they are not having regressions, that the rules are behaving as they should. So this is usually how that's done.
The idea of test-driven development is very popular. If I had a rule set of 3,000 rules about how somebody's price is calculated, and it was based on a lot of different factors, I'm not sure I could write a test case for that, because I don't know if I could look at the situation and say, okay, based on the inputs, this guy should be getting an 8% discount. Is it possible to, when the rule set is quite large, to really know what the answer should be?
It is. maybe for large cases, if you're talking about end-to-end tests, it's hard to cover all the scenarios, yes. But you can still test rules individually as you would do unit tests in a traditional programming language, and then define your set of integration cases where you actually execute all the rules and then get the results and make sure they match what the expected value is.
Would that be more of an iterative process where you run them, you look at the audit log, the business analyst looks at it and says, yeah, that's how we want it to work. That's the right answer.
For coming up with the use cases, yes, but the idea is to automate those tests as you automate any other languages tests. So you have an automated process that loads the data, executes the rules, and then compares the results with the expected results. I can see when you are creating those test cases, the analyst could use the audit log to come up with the individual cases that they want to test.
Okay. Now let's talk about the engine itself. You talked about the thousands to tens of thousands of rules. How many facts would an application have with that size of rules?
It, again, comes from even cases where you have just a few facts, a handful of facts, to cases where you have more than 1 million facts in memory, in the engine executing concurrently. The differences are for online applications like web applications where you have services, then usually it's a small set of facts and you have many of those requests coming in parallel and executing in parallel. For cases where you are heading more towards complex event processing, where you have stateful rules working there, usually you need all the state present so that you can reason over the state, so you have millions of facts all the time in the engine being evaluated concurrently.
You talked about complex event processing a couple of times. Can you define what that is?
Complex event processing is a discipline in our area that deals with processing of events. If we go very academic, basically what it does, it detects patterns on stream of events and then generates higher level events from those patterns when they are matched. Now, if we bring this into the rules context, what complex event processing does is adds the real-time component to the solution. Because when you are not dealing with events, you are basically processing requests or you're processing batches of operations. The complex event processing allows you to monitor real-time events in streams of events and then make decisions based on those streams of events.
Okay, in the first case we're talking about, we have got all the data, you hit submit, and we're going to think about it and tell you the answer. But the latter case might be something like what comes up in monitoring. The monitoring software I've generally dealt with, it can only reason about something going on a single instance, but I might not care if I have 50 servers. If one of them has high load or is running out of space, I might want to know, are 5 or more of the servers experiencing high load for 3 minutes or more? Is that the type of case where I could use complex event processing?
Yes, that's the type of case. And you can do optimizations as well. If you use, there is a part of the rules engine that deals with optimizations, and then based on this, you can start predicting those loads and saying, well, this server is going up, so before it reaches that level, I will take action and move some applications to another cluster.
And you talked about complex event processing and stateful situations. Talk a bit more. What is the state that is involved in complex event processing? How does that differ from the request or the decision service application?
In the decision service or the request-based application, you take a load of data, payload, reason about them, returns the response, and then you don't need that data anymore. So this is usually implemented as stateless, right? You throw away, the next request will be self-contained. In the Stateful case is what you mentioned. I am monitoring servers and I need to be aware all the time of what is happening and what happened during the last X time. So the time window might be hours, days, months. So that data needs to be available to the engine so it can reason over. It's not something that I am throwing away every time I receive a new event. I have to keep that. So that's the stateful part.
If we're talking about 5 or more servers are in some kind of critical state, then you would need to know the state of all the servers and how long they've been in that state, so you know when 2 minutes has expired. But then one of them was in a critical state for 1 minute, and then it went back to normal. So it's now, so you need to track these states as they change. Is that right?
That's correct. And even when you are going to take action on a server, you need to know which other server or which other cluster can I move this application to. So you have to be aware of your whole context. So it's a context-aware application in order to execute those tasks.
Is it the case that you have the decision service more large number of rules, fewer facts, and complex event processing, you might have millions of facts, but relatively fewer rules? Does it work that way?
Yes, that's very common, especially because of the requirements of the stateful cases. It's very common to split the rule base into multiple rule base or multiple knowledge bases. So you end up reducing the amount of rules so that you can deal with more data, and then each part of your process or each node of your event processing network will deal with a part of the reasoning process.
The decision service case where you have tens of thousands of rules, how long does it take for the decision service to finish executing and give you an answer?
It depends on the complexity of the rules. It's like in a database, you have, very complex queries or very simple queries, but the requirements that we see nowadays is typically under second response times.
That's pretty amazing if you can reach a decision involving tens of thousands of rules in less than a second.
Yeah, I've been involved in a project late last year where we had up to 3 million rules, and we had to respond in up to 200 microseconds, and we did that in a very small hardware. So it's possible. The optimizations are really good there.
In the case of complex event processing, I might not have there are not many websites that have more than thousands of servers, but you could have temperature sensors or motion sensors where there's an enormous number of them. What are the memory requirements for the state in cases like sensors?
What typically happens is you have to split, for larger cases, you have to split this in phases. So the first phase is basically throws away the majority of the events you are not looking for, because sensors generate typically a lot of events. So you have a pre-filter phase where the majority of the events you are not looking for is thrown away, and then you have a next phase in your network there where the events that might be interesting to you are actually processed. So by doing this in phases, you can reduce the workload to levels that are feasible in current hardware.
A little while ago, you mentioned the two types of inference, which I know from a little research on this topic. There's forward chaining and backward chaining. Can you explain what those are?
Yes, and that's exactly what they are. So forward chaining is the example we used where the reasoning is driven by data. So I have a customer with more than 10 transactions, so I flag this customer as a gold. Because this is a gold customer, then I will apply a discount to him. So this is a typical example of forward chaining or data driven reasoning. The other one, backward chaining, is the classic logic programming or goal-driven reasoning, where you have goals that you want to achieve, and those goals, they drive the reasoning process. So it's not data, but it's goals. An example would be, I want to define a route for my truck, but this route should use roads that are known to have less traffic, and then checking those roads is a sub goal of that reasoning process. So I chain those rules in terms of goals that they want to achieve instead of data that they have to reason over.
Does Drools support both types of inference?
Yes, Drools is a hybrid engine, and you can mix and match the both types of chaining inside even the same rule. So the same rule has conditions. Some of those conditions can be data driven, some of them can be goal oriented, so backward and forward chaining.
If I understand, in backward chaining, it would work backwards from the result to the facts, and it's searching for enough facts somewhere that allow it to synthesize the goal?
Yes, that's a perfect description.
Okay, and so at programming, would I go in to the Drools rules that I'm writing and say from this point, this is a backward chain from this node here?
In the technical language, in the native language, we use a exclamation point character to indicate which of those conditions are backward chaining, basically. So there is a little symbol, an exclamation point in the pattern that indicates that to the engine. I want to execute this as a backward chaining, everything else is forward chaining. Typically, developers, they have an easier time with forward chaining, so this is the most used type. For academic cases, a lot of them are backward chaining, but we support both.
I'm aware there are programming languages like Prolog that have built-in backward chaining, and it's been around in academia for many years but hasn't gotten much commercial traction. Do you have any idea why that is?
I think it's the target. I mean, when you talk about actual business rules, the rules that we implement in business applications, enterprise applications, most of them are easier to implement in forward chaining. So that's why production rules, forward chaining engines, they basically dominate the market. Prolog is one of the first backward chaining languages and has been around for a long time, but it's really used in cases that are more query driven, more research driven, or if we're talking about even like for fun algorithms like a Sudoku resolver. Sudoku resolver would be much more efficient implemented in backward chaining than forward chaining. But typical business rules, they are more efficient in forward chaining.
Okay. Now, in reading about this, I ran across a lot of discussion of the Ricci algorithm, and I think we've already talked about it a little bit, but I want to ask you first, does it stand for something, or is Ricci a word?
If I remember correctly, it means network in some language. I apologize, I don't remember exactly. But the reason it's famous is because it was the first general purpose algorithm that was able to scale to the levels that it does for business rules. One thing we have to differentiate is that this algorithm was written in 78, was published in 78, the year I was born, so it's as old as me. But there are many versions after that in different algorithms that were based on that have optimizations on top of it. So Ricci was the very first, the most famous one.
When we were talking earlier about the engine builds an efficient indexing structure that chains the rules together in an optimal order, was that the Ricci algorithm?
The basics of the network, the basics of the data structure are Ricci. The optimizations we talked about, like indexing, hashing, node sharing, those are things that came after by different researchers. They published papers on them, and they are typically implemented in engines that follow that path.
Are there any real competitors to Ricci that are not simply extensions of Ricci, but alternatives that are fundamentally different?
For forward chaining, Ricci was the best general purpose algorithm. There are others that are not applicable to the general general problems. They have niche applications. For instance, Leaps was like this. What happened is over the years, more and more optimizations were done to the Ricci algorithm, and it was morphed into other things. So there are derivatives that are better or as good as Ricci, but the fundamentals of how the algorithm works came from Ricci. Even the author that first published Ricci, he created Ricci 2 and Ricci 3 after that and other algorithms, but the fundamentals are the same.
Okay, now I want to get into JBoss, the product you work on, and the JBoss Drools engine. Starting with, what is JBoss?
So JBoss is a division of Red Hat for middleware. So all the middleware products, Java implementations from Red Hat come from this division from JBoss. It was a company, it was acquired back in 2006 by Red Hat, but all the middleware products are under that division.
What's the relationship between Drools and JBoss?
Drools is a project of JBoss. So Drools was JBoss Red Hat. They hired most of the Drools developers over the years and built a team. So that team works on developing the business rules engine. One common question is because JBoss application server is very famous, has been around for a long time. So a lot of people, when they talk about JBoss, they immediately think about the application server. The application server is one project under the JBoss umbrella. Drools is another project, and JBPM is another project, and so on and so forth.
And JBPM, that's a business process management engine. And that does raise the question. We had a show on workflow management systems a while back. Can you clarify the distinction between a workflow management and a rules engine? And I understand the case where you have a decision service, you ask it a question that could be a step in a business process, but some of these complex event processing cases where there are events happening that's starting to sound a little more like a business process. Is there a clear distinction between the two?
There is. Basically, the easiest way to say is, business process management solutions in JBPM, they implement workflows, they implement processes. So processes are usually things that happen in steps, and you have a very clear flow. Rules, on the other side, or decision services, they are more unstructured. They define scenarios. When those scenarios are found or are matched, something happens. They execute an action or they return a value, right? But if we look at business applications and the modeling of logic, you basically have four pillars, if you will. One is ontologies, that's the model, how you build the domain model of an application. Then you have the business processes that define the structure, the very well-defined flow of actions that have to happen. The rules that are the unstructured actions that have to be taken based on scenarios, and the complex event processing, that's basically the real-time component. And all those four pillars, they have to work together. And we have a very close relationship with JBPM. We use the same API, we use algorithms integrated in there, so we work together to try to provide the solution that allows users to model business problems, basically.
It sounds like very powerful modeling tools when you get all of those combined.
Yes. It basically allows you to define business logic outside imperative application code. And that is very powerful. I can't stress enough the importance that life cycle or the independent life cycle has on how agile those companies can go, how they can decrease time to market, and so on and so forth. I'm not going into much details here, but
yeah. Okay, now I'm setting up the JBoss Drools. Are there other tools like IDE, a debugger, things that will help in the development process?
Yes, we have a plugin for Eclipse in terms of IDE, so you can use Eclipse to develop the rules. You can, debug, set breakpoints, inspect variables, things like this. Our main tooling is based on a web application, so it's web tooling, where you can define rules, and inside the same tooling you can define processes as well and models as well. So our main tools are web-based, but we do have Eclipse plugin for IDE.
Do you treat the rules more like code, where the rules might be checked into Git and they're version controlled, and then they go through a test cycle? Are the rules more like data elements in a database where you could deploy a new rule by essentially doing an insert into some kind of store?
Both. We do use code versioning control behind the scenes, so we do use Git, for instance, as repository. It has the tests lifecycle and etc. But the engine allows the rules to be treated as data from an application point of view. So you can redeploy rules at any time without stopping the application at all. It's completely dynamic. It's live all the time. When you redeploy a new rule, the new rule takes effect, and there is no need for downtime.
I have one more question that we can wrap up with. In the early days of artificial intelligence, when perhaps researchers were much more optimistic about the field, it was believed that any kind of expertise or human intelligence could be reduced to rules. So that researchers would go around and interview experts and say things like, Mr. Expert or Dr. Expert, how did you make this medical diagnosis? And very diligently write down all the rules. Then they found that this didn't really capture it because the experts were maybe not cooperating, and they would not be able to explain all the rules or say, yes, but there's this exception. There's a researcher named Dreyfus who wrote a couple of books on this. One of them is called What Computers Can't Do. And he disputed that rules could really capture human expertise. And now, in the last few years, we've had this explosion of machine learning techniques, neural nets, which are data-driven, or something like neural nets where you don't really have a model, a cognitive model of how the decision is made. So I'm wondering, do we see maybe chaining together of a machine learning step with a classifier that creates facts that then you can analyze these facts with rules? And how did all these things play together in the modern world?
It's a very interesting field. There are many applications where you can combine those technologies or those researches to produce very amazing results. If we are looking at businesses, I think this is much more advanced than what business usually needs, but there is a number of things that could be achieved with that. Having said that, I think the current understanding of the market is that it's more important at the moment to provide systems that support decisions than systems that make decisions by themselves. So there is a lot of research in terms of the supported clinical decisions or supported lawmaking decisions, but this is really on supporting people, and people would look at those conclusions and then derive their own conclusions from that. I don't see much in terms of replacing completely or automating completely those complex decisions, as it was thought it would be possible in the gold age of AI.
In the case of decision support, would an example of that be then the physician might enter clinical signs and symptoms, and the system come back and say, here's some possible diagnosis, and the doctor still is going to look at it and say, I'm here, I know it's this or it's not that, but you are hopefully suggesting something the doctor might not have thought of.
That's basically the idea, but more importantly, the system will even tell you these are the possibilities, but if, for instance, you ask for this other exam from the patient, then you can exclude from the results of the exams these options here, or you can confirm that one. So basically the system would lay out the map for the physician so that the physician can, understand better where he is, or help him find where he is in that situation.
So let's go back to the business example. I'm sure that the company that's giving loans has a lot of rules, and you could decide whether to give someone a loan or not based on the rules. But I'm wondering if they came up with all those rules because that was the only way to do it, or they didn't have a better way. And if the goal is to give loans to people who will pay them back and not to give loans to people who default, would perhaps a machine learning approach give you a better loan performance than rules? Do we know?
For specifically for the insurance industry, what I've seen more is really driven by requirements and by policies of the company. But there are areas where it's not really possible to define those rules in advance, and those rules are mined. Very easy examples: you go into Amazon website and you make a purchase, and then next time you go to the website, it will suggest other products. Maybe you didn't even thought about those other products, but they fit your profile. It's something that you would like to have. And those are rule-based systems, but the rules are created based on extraction of data and machine learning.
Great. Well, we've covered a lot of material here. Is there anything else you'd like to add that we haven't talked about?
Oh, I think the area is a passion of mine. I recommend anyone interested to join us in the community, talk, discuss, look for topics that interest them. We are always happy to talk. But that's it. Thank you very much for having me. It was a pleasure.
And if people would like to learn more about you, do you write, blog, Twitter? Where can people go?
The drools.org website is the entry point, and from there you have the URLs for the blog, you have the URLs for the chat room, for the mailing list, for everything. So drools.org, and then from there you'll find everything you need.
Great. Edson, thank you very much for speaking to Software Engineering Radio.
Thank you.
For Software Engineering Radio, this has been Robert Blumen.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.